what we are going to learn in this lecture: meaning of probability and mathematical or classical approach of probability. Many times in our daily life, we come with the situations like, what is my chance of winning in any game? Or, what is my chance of getting first in class? When these situations are applied in mathematics, these take the concept of probability. So, what is a probability? Probability means numerical expression of occurrence or non-occurrence of an event on the basis of certain definite mathematical theories. So, probability means when we use certain definite mathematical theories and we say that the chance of this coming of this event is so and so, it means we are doing probability. Now, mathematical or classical approach of probability. This is the oldest and simplest approach in measuring probability. According to this approach, the probability of occurrence of an event is in the ratio of number of favorable events to number of total possible events. Therefore, probability of occurring an event, denoted by P in this case, is equal to number of favorable events divided by total number of likely events. Say for example, if there are 4 red balls and 5 white balls in a bag, and the probability of the ball being red in case of one ball is drawn will be 4 by 9. How it is? As number of favorable events, that is ball being red, is 4, and total number of likely events, that is all balls in a bag, is 9. Therefore, probability will be 4 by 9. Now, let's discuss some important terms to be used in this chapter of probability. First is experiment. What is it? It is described as performance that produces certain result. So, any performance is called an experiment here. Second is, what is random experiment? An experiment is said to be random if the results of the experiment depend on chance only. For example, if a coin is tossed, then we get two outcomes, head and tail. We are not certain about the result. We may get a head or tail on tossing a coin once. Thus, tossing of a coin is an example of random experiment. Third one is event. The result or outcome of random experiment are known as events. There are two types of events. First one is simple or elementary. An event is known to be simple if it cannot be divided or decomposed into further events, like tossing a coin once, while give result as head or tail. So it is simple event. Second one is composite or compound event. When event can be decomposed into two or more events, it is called composite event, like getting a head when a coin is tossed twice. So we get the result head, tail, or tail and head. So it is composite or compound event. Fourth one is mutually exclusive events. It is a situation in which two students in a class hate each other so much that they cannot sit together in a bench. So mutually exclusive events means occurrence of one event implies the non-occurrence of the other event. Say for example, once a coin is tossed, we get two mutually exclusive events as head and tail. Means if head comes, then tail can't come in that event, and if tail comes in an event, then head cannot come in that event. Fifth one is exhaustive events. The events A1, A2, A3 and so on are known to form an exhaustive set if one of these events must necessarily occur. Say for example, if a coin is tossed, then it is a surety to get a head or a tail. So it is called exhaustive events. Sixth is equally likely events. When no event is expected to occur more frequently as compared to other events of set. So it is called equally likely events. Say for example, there is no reason to assume that head would occur more frequently as compared to tail. Both are equally likely events. So both can come equal number of times. Now some points to remember. First is probability of an event lies between 0 and 1. Means the value of probability will always be from 0 to 1, both exclusive. That is, it is greater than equal to 0 or less than or equal to 1. And if probability on an event is 0, it is known to be an impossible event because the probability of that event is 0. So it cannot come. So it is an impossible event. And when probability of any event is 1, it is known to be a sure event because the probability is 1, means that event should happen. Second is non-occurrence of event A is denoted by A dash and it is known as complementary event of A. So the event A along with its complementary A dash forms a set of mutually exclusive and exhaustive events. That is, we can say PA plus PA dash, or you can say probability of A plus probability of P dash will always be equal to 1. Now let's solve a question. Our first question is, a coin is tossed 3 times. So what is the probability of getting? First part is 2 heads and second part is at least 2 heads. The outcomes of 3 tosses of a coin can be shown by the following diagram. Start from here. If we do our first toss, we can get 2 events, head or tail. And on getting head and further tossing, we may get a head or tail. And if in our first toss we got tail, then also we have 2 outcomes in second toss, either head or tail. Then in case of third one, we may have head or tail after head, or we may have head or tail after tail. Similarly for other head and tail. So here the possible outcomes of the event are, first head comes, then in second toss the head comes, and in third toss also the head comes. Or in first 2 tosses head comes and in third toss tail comes. Or we can say there another outcome may be head comes, then tail comes, then head comes. And in next outcome we may have head, tail and so on. So there are total number of events as 8. Therefore, the probability of getting 2 heads are, first we will discuss our favorable events. What is our favorable events of 2 head? It may be head head tail, head tail head or tail head head. It means we have 3 events. So probability of A will be favorable events upon total number of likely events, that is 3 upon 8. Second is probability of getting at least 2 heads. At least 2 heads means we may have 2 heads or 3 heads. So favorable events here are head head head, head head tail head and tail head head. So in total we have 4 events. So probability of B is equal to 4 upon 8, or we can solve it further as 0.5. Our next question is, what is the probability of drawing a king in a draw from a pack of 52 cards? First of all, if you are not aware about the cards, then it is my duty to tell you about this. In a pack of 52 cards, there is a division of cards into 4 categories. That is, 13 cards are of spade, 13 cards are of diamond, 13 are of heart and another 13 are of club. And also 26 cards are of red color and 26 cards are of black color. In each category mentioned above, there is one king, one queen, one jack, and cards are numbered as 2, 3, 4, 5, 6 up to 10 and one ace. Now coming back to the question, we have favorable outcomes as 4 because we have to calculate the probability of drawing a king. So there are 4 kings, one of spade, one of diamond, one of heart and one of club. So there are 4 kings. So favorable outcomes are 4 and total outcomes are 52. So probability of A will be 4 upon 52, or we can say 1 upon 13. Our second question is, what is the probability of drawing a card of red color? As we have just studied that in a pack of 52 cards, there are 2 categories of colors. There are 26 cards of red color and 26 cards of black color. So we have favorable outcomes as 26 because 26 cards are of red color. So probability of A will be 26 upon 52, that is 1 by 2. Our third question is, what is the probability of drawing a king of diamond? As we have just learnt that there are 13 diamonds in a pack of 52 cards, and in that 13 cards we have one king. So favorable outcomes are 1 and probability of A will be 1 by 52. Our third question is, a dice is rolled twice. What is a dice? As you all must have played Ludo in your childhood, so that is the dice. What is the probability of getting a difference of 2 points? What is asked in the question? You roll a dice twice, and what is the probability that the difference of 2 points comes in your rolling? But first we will have to learn a concept here. If result of an event is P and experiment is repeated Q times, then total number of outcomes is P to the power Q. In the present question, total number of outcomes will be calculated as result of an event is 6 outcomes because in a dice there are numbers from 1 to 6. As you all know, you must have played Ludo and you know there are 6 outcomes, 1, 2, 3, 4, 5 and 6. And here we are rolling it twice, so total number of outcomes will be 6 to the power 2, that is 36. Now we have 2 throws. So first column will be of first row, second column will be of second row, and third column will be of difference because we want a difference of 2 between 2 throws. So it may be, how the difference of 2 comes? It may come when the first row shows 1 and second row shows 3, or first row shows 2 and second row shows 4, or first row comes 3 and in second row comes 5, or in first row comes 3 or in second row comes 1, and so on. So there are total 8 possible outcomes for that. So probability of A will be 8 upon 36, or you can say 2 upon 9. Now what you have to do? You have to revise all these concepts from your study material and do some questions also and ask query if any. Thank you. This was end of lecture 31, Probability Part 1.